pulled up. Okay, can you, Nigel and Chris, can you guys see this okay?
Mm-hmm. Can see it fine.
Great. Okay, so I came into the Viper editor, and the reason, I mean, you guys are welcome. Honestly, I should probably specify this ahead of time. If you guys are more comfortable with Java style syntax, Solidity is not a bad language at all. Viper tends to be a little bit leaner, so the syntax is modeled 100% off of Python. I just thought it would be a little easier. But honestly, feel free. If you feel that one's better than the other or easier, you're welcome to. But just what I did here was I created a Facebook Marketplace smart contract in Viper. And I just put my code in here and then came down to the Viper compiler and just chose remote compiler. And I'm just going to compile this code and starts to spin here. Okay. So my code compiles successfully. Nigel, before we pop off, I will, if you haven't seen it already, I will send you a link to that other IDE that I mentioned that will help you with some debugging. This IDE, by the way, was updated since last semester. It used to be much worse than this. It's actually a lot better than Miriam's experience, I think.
It was a lot worse.
Yeah, it was more difficult. But so I noticed I was able to get a green check. So let's just assume for the time being, you're able to get your green check, that your code checks out. So I've compiled my code successfully. And then what I'm going to do is I can actually deploy that code into the active testing blockchain. So you're going to, this is in the instructions, but you're going to select injected Web3. And here, if you have the MetaMask plugin already installed in your browser, it should probably detect your account automatically for you. But if not, you can just click add an account and you're going to choose your Ether address here. I'm going to leave the gas limit alone. This is plenty of gas so that someone will take and process your job. So I would leave this as the default. And then for the number of way, since the transaction is a 5-way transaction, we're going to want to do 5 here. And just a note on what way are. Think of a penny. If one ETH coin was a penny, and you divided it into 1 billion pieces, then you took each of those 1 billion pieces and divided those into a billion pieces each. So you would end up with 1 quintillion pieces. That's basically what a single way is compared to Ether. It is 1 billionth of 1 billionth of an Ether. So it's basically almost worthless. So when we spend, what is this, 3 million? No, 30 million? What does that number say? So this is 3 million in gas. That's nothing. It's just like a very, very, very small fraction. So Way, feel free to spend those as much as you want. Ether, I don't recommend spending 3 million Ether. That's a lot. As of today, how much was an Ether worth today, Miriam? Like 325 bucks?
Let me check. That sounds about right, though. Sorry, it's not as easy to find as I thought it would be.
Okay.
$319.
319, okay. So divide that by a billion, then divide that by a billion again, and that's what 1 way equals. So we're going to provide it 5 because our transaction, what we're basically doing here is us as the people who are putting the transaction forth. We are putting a little bit of almost like a deposit on the contract to start. And this is insurance for the person that we're entering into the contract with, that we're not going to do something shisty. right? Like just cancel the sale after they pay, right? So this puts skin in the game for us so that if something malicious happens, we'll lose this money. So this kind of proves to the person on the other end that we are serious about this transaction, and there's a financial or fiscal way to enforce it. And then the other thing we're going to do is our constructor here takes two fields, and it takes the price of the item. So again, this is kind of like the scenario is a Facebook marketplace. It's going to be the price of the item, which is going to be 5-way. And the other parameter that we're passing into our constructor is the duration. So this is the number of seconds that we want the sale to be active for. So in our case, I'll do.
You
Sure.
can also, if you show the dropdown right next to the box that you're typing in, it'll show each of the, yeah, that might be easier to see.
Yep. So what we're just doing here is you see that it gets these two fields, the price and the duration. It literally parses them out of the constructor right here. And so what Miriam's saying is you can nicely see if you pop it down, and you can see the mapping field to field. So we're going to send it 5-way, and we're going to persist it for 1 hour. So 60 seconds times 60 minutes. And that's all we need to do to deploy our contract. So we're going to hit transact, and we're going to deploy this contract to the test blockchain. And in order to do that, it charges us a gas fee. And this gas fee is basically, it's a charge on us to the Ethereum network. These are the fractions of Ether coins that go out to the people who do the coin mining, right? So they get value if they mine our transaction and verify it and then add it to a blockchain for us. We pay for their services because it takes up memory, it takes up CPU cycles, it takes up power on their computer. So that's what gas is. So this is asking me, well, hey, look, yeah, we can post this transaction to the ledger for you. It's going to cost you a little bit of money. Perfectly fine with this, so we'll hit confirm. So it basically went into my Ether wallet and said, hey, do you want to pay for this? And I said yes, and you can see that the creation of my FBMP, Facebook Marketplace contract, is now pending. So I'll show you the build process for it. Oh, you can't see it.
No, we can see it.
Oh, you can see it when I switch tabs?
Mm-hmm.
Oh, awesome. Okay, so here's the hash of the transaction. And we can see that we don't know yet which block in the blockchain we're being added to, but people are actively mining the transaction right now. It's only going to take just a few seconds. Well, it's not too bad, maybe a minute, minute and a half, but I'll let it finish. And then once we're done, we'll get an address for our contract. And then once I have that address, I'm going to share that with Miriam. And I'm going to share the executable code as well. And Miriam is going to interface with my contract, and we're going to do the sale basically live in front of you guys, but through the smart contract. So that didn't take long at all. The cool thing to note is this transaction fee. You can suggest what you want to pay in gas, but really you might as well go with this number because this is basically derived from the offers that people are accepting to do the mining right now. So if I only offer them, 0.00636 Ether, people will have the option not to pick up your job and verify it. So you have to kind of give them enough money that they're like, okay, yeah, I'll pick this up and I'll mine it for you. And you can see that it has produced this wonderful contract for us right here. So I'm going to copy that, and I'll click on the contract so we can also view this. There won't be much to see. Okay, but we can see, and this is stuff that you cannot tamper with because it's all based on like a really large hash tree, a chain of hashes, right? This blockchain. You can't alter something without messing everything else above it up. Right? So you can't just come in and say, so this is my ID right here. This is my creator address, this A19C. So if I look in MetaMask, you can see that that's my account. So I'm the one who created this contract. I cannot come in here and modify this and say, oh, no, it was actually Miriam that created this, because that will mess up the blockchain, because that's the nature of a hash function. Any change in the input, everybody's going to look at it and say, wait a second, this changed. This block is no longer valid. Like something has happened. Someone has tried to alter the contract creator. So these fields are finite and cannot be altered without the community at large being able to detect them. That's pretty cool. So I'm going to copy this address. And Miriam, how would you like me to send it to you? May I email this over to you?
Sure.
Okay.
And your
Yeah, I'll send you the code in an email.
API code. Has anyone been able to attempt thus far what we've showed in the tutorial?
No, I haven't yet. Actually, I kind of wish I went through this already, but it's good to kind of go along with you guys so I can kind of be prepared.
Miriam, real quickly, I'm sorry not to interrupt, but I do want to show you guys, Chris and Nigel, this step too. The ABI, this is the application bytecode. This is the code that there's something called an EVM. It's an Ethereum virtual machine. And that Ethereum virtual machine is what is running on all the clients in the Ethereum network. So all the ones that are doing the work and the mining of these transactions. So this bytecode is a generic way that the Ethereum virtual machine running on Windows and running on Mac and running on Linux and whatever other operating system, this is a generic bytecode that you can share that will be interpreted by any Ethereum virtual machine. And you'll need this in your assignment. So I wanted you to see that if you come in here into the Viper interface, after you compile it, you just click on the ABI tab and copy ABI. And this will give you all of the bytecode specific to your contract. So this is where you get it. Just wanted you guys to get a chance to see that.
So why do you need the ABI? I thought the contract was in the blockchain.
The contract is, but now if you want to go and interact with the contract, right, the contract is just written in Python code. So you need a way to execute the methods in your contract, right? It's a piece of executable code. So how do you execute it? And that's what the bytecode is for.
Okay. Sorry, I just realized that I had turned my sound off. Did you email the ABI code?
No, I wanted to show them that step about getting the ABI out of the editor.
Gotcha. Okay.
I'm sending it to you right now. Nigel, did that help?
I guess I don't understand what the contract is then, because I thought that was the actual program, or the bytecode being put in there was the contract.
Just one second. I'm just sending this code over to Miriam. So you're right, but you need a way to be able to interact with the contract, right?
Yeah, I get it. So you know, a regular API is the program, and it's just documentation to say how do you interact with this program. But in this case, you're sending actual bytecode over.
Right. Oh, I see. So oh, gotcha. Okay. I see what you're saying. So we're using an extension to interact with this particular contract. That's what the My Ether wallet is. Did you see the My Ether wallet?
Yeah, I have that installed. So that needs the bytecode for your contract. Is that what you're saying?
Yes, in our case, yeah. So since we're using My Ether wallet, it needs a way, it can't get the code. So we have to provide it the code to be able to interact with it. So we're going to give it the address of the contract, and then we're going to give it the bytecode so that it can actually interact with it, and it's going to put our transactions against that contract in the ledger, which we'll actually see happen.
So if I got that bytecode from whatever block that contract is written in, or if I got the contract from whatever block it's written in, I could derive that bytecode again.
If you got that, sorry, can you say that one more time?
So if I went and looked at some random contract in some block, could I derive the API bytecode and give it to my Ether wallet?
Yeah, that's kind of the point of these contracts. So some of them are public, some of them are not so public. But if I wanted to write a contract that you couldn't interact with, then inside my source code somewhere, I would deny all other wallet addresses other than the one I wanted to do the transaction with. You there?
Yeah. So my Ether wallet is just using us copying and pasting that as a convenience. But in theory, you can derive everything you need from the contract that's in the blockchain.
Yes, yeah, exactly. So I'll show you what my Ether wallet looks like. I'll actually share my screen again here, and I'll take that bytecode, and I'm actually going to put it inside the tool, and the tool is going to link it to my wallet. So it's going to know that it's my identity interacting with this contract. So there's no way that I can forge this. Once I do something to this contract, I can't then say, oh, well, that wasn't me. No, there's an entry in the ledger, and it was verified. So this is immutable.
And I just did the same with your contract hash and ABI code. So now my Ether wallet is also connected to this contract, and then I can proceed to buy something from your marketplace.
Exactly. So I'm going to pull the contract up in here, clear the existing one. I hate this giant tab from Zoom. Can I move this? Oh, I can. Nice.
Yeah, I don't think we noticed a difference.
Oh, so you can't see it. Okay, good. That's good to know. So I'm going to take the contract address here, paste it there, and then I'm going to take the ABI code, just copy ABI. I'm going to put that in my Ether wallet as well. I'm going to hit continue. Okay, so now it knows that I am interacting with the contract. It looks like this loaded successfully. And the way that we can tell is, well, we didn't get any error messages for one, but when I click on select item, this purchase item, cancel sale, refund purchase, these are all methods that I defined in my source code over here, right? So here's a method called purchase item. Here's a method called cancel sale. And that's exactly what I'm seeing here. These are the methods, and this is a way for me to interact with them. And in addition to the methods, I'm also seeing the variables that I asked you to describe and declare at the top of the source code. So we can actually check on the source of these, or on the values of these variables. So for instance, initially my code sets the contract, it says sold is equal to false. So the item starts out initially as unsold. So if I click on sold, this should access the contract and get the current state of the value, which should be false. So this is good. So I'm able to interact with the contract and I can get this value. I can see who is the seller. The seller is A19C4. Well, that should be me. And if I check my wallet address, A19C4. So that's me. So this is proof that this is the contract that I just created. And if I look for the buyer is initially null. And in my code, I set that to be nobody in particular to start. So Miriam, you mentioned that you imported this contract into your MyEther wallet. Can you try to purchase the item?
Sure.
Here is the amount of, I'll send this to you in chat. This is the amount of Ether you need to pay for it.
I have to pay for this?
Yes, with your 20 tokens that you took from Nigel.
I gotcha. Okay.
Nigel, if you get a chance, if you'd like to throw up your wallet address inside of chat, I think Miriam wouldn't have any problem sending it a couple coins over to you.
Yeah, thanks.
Yeah, of course. I'm sorry that you had so many issues with it. All right, I got a success on purchasing an item from you.
Okay, so Miriam has successfully placed a purchase for the item. So I'm going to go to sold, and you would think the answer would be true. The answer is not true, it's false. Any idea why the result is false, even though Miriam just purchased it? There is a valid reason for this, by the way.
I have to imagine it hasn't been mined yet.
It's exactly right. The transaction has not been added to the blockchain. So though she submitted it successfully, somebody's probably working on it right now. And I'll just click off of it and try to click back onto it. There you go. So now we see that the item has been sold. And we can also check one of the other things that I'm keeping, I believe, was the price. So the price of the item. So I know that Miriam tried to pay 5 Wei for it. So the next thing that I need to do, so I'm the, as the seller, I need to ship the item to Miriam. So I'm going to go ahead and, where's my method for shipping? I'm going to do ship item. Ship item does not require any ETH, and you should not send it any ETH or it will bark at you. So when you do the ship item, it's going to send it no value whatsoever. All right, and this is great. So it's trying to execute that command for me. And notice that MetaMask popped up. And it's basically just asking me for gas. It's saying, okay, well, we can do that transaction for you and we'll get it mined. But don't forget, we're going to charge you a little bit of a gas fee. So before they do, they ask you to make sure that that's okay. So we can go ahead and confirm it. And it shows you right here, you can see that it's pending. And I have the ability, you can actually spend more gas in real time and someone's likely to pick up your task faster if you spend more on it. Okay, so I think the transaction was probably good. So if I come here now and I check the shipped flag, we see that my item is now marked as shipped. So that's good. So we're making our way through the contract. So the thing that hasn't happened yet is, notice I have a flag called received. And in my contract, the only person that can set the received flag is the buyer, which is Miriam. Okay, so she hasn't received it yet. What's that?
Oh, I'm gonna click received.
Okay, perfect. The other thing I'll do is I'll just verify the buyer for you guys so that you can see it was indeed updated with Miriam's address. Remember, initially this was all zeros.
Yep, that's me.
When Miriam did purchase item, okay, that's your wallet, right? Good.
Mm-hmm.
Okay.
All right, that was successful for me.
Okay, so let's refresh the receive flag. Let's just see if Miriam received it. Did it finish, when you say successful, did it finish mining?
don't know. I think so.
Not yet. Did it say complete in MetaMask?
No, not yet.
Right down here, under, you see the contract interaction. Did this go blue for you yet?
Okay, just did.
Okay, perfect. Awesome. So now if I go to, you marked it as received, right?
Mm-hmm.
Okay, well, I did too many transactions and I ran out of gas. Great. But anyway, I did too much. I didn't have enough gas on the transaction, as you saw. But you get the idea. So we were interacting in real time. And the cool thing is that we can also, if we look up this contract now on the blockchain, we can actually see a list of the transactions that took place. So I'm going to take this contract address and actually look it up here. And you can see the transactions actually taking place, which I think is pretty neat. Here's the hashes of the transaction. So there's the contract creation by A19C, that's me. And then you can see 5-way was added to the contract by E63D, that was Miriam. Then I marked the item as having been shipped, that's my wallet. And then Miriam went ahead and marked the address or the package as having been received at that address. And so here's her wallet address. So we can see each of the transactions that we just stepped through. They're contained here on the contract. And again, these fields are completely immutable. If you try to make any changes to these whatsoever, it's going to be detected by the public immediately. You're going to get a bad reputation and then never be permitted to participate with that wallet address ever again. So is that helpful in kind of taking you guys through what the workflow is and how to use my Ether wallet as the client to the contract, Nigel?
Yeah, I guess that is definitely helpful. I wasn't having so many problems with following the flow of things, but the actual, an errors I would get while I was compiling.
Okay, did you, I'm sorry, I can't remember if I asked you this, I'm sorry, but did you see the other Viper compiler online?
Is it the Ethereum Ether.io or something like that?
Yes, that's the one.
Yeah, I used a couple of them. And the problem is that depending on the compiler, it looks like different type definitions are there or they're not. So for instance, the way value, I think, is gone now in the, .2.0 version. So there's a bunch of different things that you have to fiddle with to get it right. And then I stopped on the online version because it was saying, oh, there's no such thing as the message object, which, according to the documentation, it's part of the environment, right? You get the message block and I forget one other thing, right?
Yeah, and you can
the
see
message and the block.
I have it right here in my code, where I have a public payable method that you can put value onto. I'm using message.value here. So this was my code from last semester, actually. This was my solution to the homework when I built it in the spring. So I know that the debugging here isn't great, but I just recommend just go through one function at a time. I just write a couple lines each.
Yeah. So you already have that public payable init listed in the homework. So I just tried to do that, and it will error out when I add the message.sender line assigned to self.sender.
Yeah.
I was like, what is going on?
You kind of need to play around with it. Earlier, whenever I had brought up my assignment, I tried running the first variable, literally just compiling price, public, way value, and then that errored out. So I tried compiling some other variables first, and then I added that one in later. I know it's frustrating, especially because you don't get such helpful feedback, although this is better. But yeah, try to go through it one by line, and if one function doesn't seem to work, try to see if you can move on to the next one.
Wow.
You
Yeah,
can
so
feel
I
free.
spent some time trying to get the local compiler to work because I was like, oh, you know, if I get the local one working, maybe they'll actually give me some errors I can, you know, take some action on. And I could not find any documentation on how to set up a local compiler either. There's that pip install Viper, but that I don't see any interface to set up for the Remix IDE.
Yeah, it was trying to do the local compiler last semester. That's why I stuck with the web. I got it working like kind of somehow. It's one of those things where you change 10 things, then all of a sudden it works and you don't remember any of the 10 things that you changed because there were so many. But if you want to send me, I recommend to like try to do all the declarations and the constructor. And if you want to send that over to me, if you're still having difficulty compiling it, shoot it my way. I'll touch it up for you, let you know what the issue was, and I can send it back to you.
Yeah,
Okay.
same here as well.
Yeah, just looking at your code, I noticed that I don't have everything listed as public, or you have most things listed as public, and I was just trying to cherry pick. So maybe that's the issue, but I didn't understand what in the world that would have to do with message sender assigned to self sender, because I set that as public. So yeah, that's wonky.
Yeah, okay, I got you. I want to say maybe it's the case that private methods, maybe they don't get the message passed into it. Maybe.
Yeah, there was a whole thing last semester about private variables. And I remember just as a class, we kind of came to the consensus not to ever use them. I don't remember exactly what came out of it, but yes, no private variables are needed.
Gotcha.
And we can get back to you on the exact reasoning. I'd have to look it up.
I mean, that's okay for our purposes, 100%. I would say for the purposes of actually writing a contract, if you ever wanted to publish one,
Sure.
definitely there are methods in certain instance variables that you would want to be private. But for our purposes, it's for getting it working, it's fine.
Yeah, and Nigel, I did send you that test ether if you want to go ahead and refresh and see if you got it.
And Chris, does give you so now you've seen it all end to end, just give you at least I know it was a little bit fast, but trust me, I think seeing this first and then getting started, I'm guessing that's probably a pretty good strategy.
Yeah, definitely. I'm glad just to even see the buttonology in this IDE. That's that helps right there. So it's good. Like knowing my luck, I'll probably run into some issues as well. Also,
I did
I'm
too.
glad you're
Yeah, I taught this all to myself in a week. I decided, you know what, this is really going to make a great assignment. Granted, a little frustrating, but still, I think it's really important to have something new and fun and innovative in the class. So that's why I took a week. I definitely went through the same struggles. But notice I'm leaving the screen up here so you can at least see the constructor and all the variables that you're going to need, like kind of like hint. Hopefully,
yeah,
this started on the right foot.
No, that's good. Yeah, thanks.
Sure.
Yeah,
So
I did get
sorry, do you guys have more questions?
Just real quick, you said there's a debugger in this IDE, or
No,
was that just trying to compile
another one
it?
online. It's much better. So if you do something stupid here, I'll show you. For example, if I do Viper, so I deleted a parenthesis and I compile it.
Oh, I see. Okay.
It catches it. It shows you this, but then it's like kind of unclear how to find the messages. Like click debug, and this is really just debugging the transaction. So I never really know what's the error. So unless
Doesn't
we're
say a line number or anything?
wrong, but I would not recommend using this for debugging. And that's
Okay.
what Nigel was mentioning. If you just Google Viper compiler, there's one, it's like Ether, was it ether.io?
Yeah, but you have to set the compiler level or the Viper version to like 1.0.11 to get the right type definitions like way value and timestamp and things like that. Otherwise, they're like the uint 256, and that took me a minute too, because I think they've gotten rid of those apparently.
Yeah, I'm using, so notice in my code here, this is from last semester, and I remember seeing something in the documentation about it then. You should probably, yeah, I think you should be using uint 256. I don't think they have the way type anymore. But that was true as of last semester. I do remember that. So yeah, definitely I would say use uint 256.
Yeah, but the directions say, create this as this type, which is a way value type. So that was, why I was trying to figure out what was wrong.
Yeah, I think way value is just a type def for 256 or vice versa, but I think they might have actually removed, like you said, remove that type def at some point. And that's the, yeah, thanks. I'll be sure to update that in the assignment. Thank you for pointing that out. Okay, so any other questions before we wrap up?
I was just kind of surprised that these contracts, how, even though the crypto currency is not, hackable really. I mean, there's different things you can do with it. These contracts, are written by goobers like me. So there's got to be a lot of bad contracts out there. What happens with those?
When you say bad contract, do you mean like written in a way that's not perfect, like the protocol is not perfectly secure?
Right. Like, let's say, I don't write the contract correctly, and there's a way that somebody can get the product or get the money without making a payment or something like that. And
Yeah, you can see right here. I have a method for canceling the sale. And so notice that I put, I'm asserting that the item was not sold. And this only gets sold when Miriam clicked purchase item. So this is an example of something I feel like I did well. I said, so this tells Miriam I cannot cancel the sale after she has purchased it. But I think what you're saying is, what if I didn't have this line in here, right?
yeah, basically.
Yeah, so there's no guarantee against like the correctness of the contracts. So you're right. I like the word goober because that's exactly how I felt when I wrote mine. I'm like, there's probably 100 ways that someone could abuse this and get their item, and I don't get my payment. But there's guidance for that, but there's nothing enforced at the protocol level that says you can't write a bad contract. So there are actually companies now though that specialize in cryptographic contracts. But I'm with you. I looked into like smart contract builders, and a couple of primitive ones exist, but nothing that I would really trust. So there's nothing to guarantee that a contract is correct, though it is secure. Still subject to the author, and not much you can really do to get around that.
Yeah, I was just curious. You can't really hack a blockchain, but I'm curious how much contract hacking goes on.
That's a really good question. This is actually the one and only contract that I myself have ever written. So I haven't spent a great deal of time. I did look closely at the ones that were posted online. in the documentation for Viper, and they look pretty reasonable, I think. But I'm with you. If I were a novice and just wanted to write a smart contract, I wouldn't trust myself. So yeah, no, it's a very good point. It's still subject to the user in the end, the person who wrote it. That's a good point. So I think Miriam, you have just a couple minutes left. Can you please take us through? Do you mind that article on the blockchain and Docker? Miriam, if you're still there, you are still on.
Sorry, I'm on mute. There was a cool article that popped up probably about 4 to 6 weeks ago about Docker and using Docker images for crypto mining. So causing a distributed denial of service attack and using the resources of your container and the resources, or thereby the resources of your host for crypto mining. So I guess just a quick review. We've used Docker in a couple of assignments thus far. So it's a platform as a service for Linux and Windows that allows developers to deploy or test applications in a contained virtual environment. And the point is to keep it isolated or segregated, separate in some way from the host system that it's running on. And you can deploy it really quick, and you can pull images from various sources or from the Docker Hub and deploy an environment that you need really quickly, and you can just as quickly get rid of it as well. So this I guess environment has started catching the eye of attackers, which I think is really interesting, that attackers have usually scanned devices that have open SSH ports or Telnet ports capabilities open. Well, now they're searching for Docker servers with exposed ports, which I think is a really cool and interesting new attack vector that I think is pretty recent when you think about threat vectors and our environment and things that we would have to protect against. So in this case, the article mentioned 2 different types of malware that basically leveraged the Docker Hub to host the image, and embedded in the image was malware. And so when people pulled that Docker image to deploy on their machine, a Python script would trigger the malware, set it off, and it was able to start mining cryptocurrency. There were about 2 million of these Docker images that were pulled over, I believe, a period of 4 years. And the one that the article noted was that one ID wallet was able to get about $36,000 in a corresponding cryptocurrency. So that's how much it was able to go to mine. And last week we talked about how malware can remain anonymous and what kind of methods and tools that malware can do to itself to avoid detection. So in this case, it used the Tor service to anonymize itself on the network and evade detection. And the Tor service is something that we will learn about and cover in the last week of this class. So it will definitely come up again and maybe make more sense at that point of how it's useful for keeping things private. And So in response to this, I guess, do y'all have any ideas of how we might be able to try to prevent our containers from falling into this similar scenario, or ourselves from falling into this scenario with different containers that we deploy?
You mentioned that they were scanning for ports, right? So I guess just closing those exposed ports, and maybe terminating like any, like, you know, pulling up some containers. If there's some containers that you don't recognize, maybe terminate them. I can't think of anything else.
Can you think of any
That would be my
to
first.
do that, Chris?
I'm sorry.
Can you think of any tools that would automate that for you? Checking to see if there's vulnerable ports that are open on your container?
Checking if there are vulnerable ports. No, I can't think of any.
We used it in class.
Wait, for Docker containers?
Yep.
Oh,
Remember Anchor?
yeah, Anchor. You're right. Yes.
Yeah, that's
I do remember
exactly
that. That's right.
exactly what you're saying. That's one of the checks that Anchor does, is it will check to see what
yeah.
ports the Docker container has exposed, or whatever kind of container you're using has exposed, and it will give you a report. Say, hey, you have all these open. Did you mean to?
Oh yeah. That's right. Okay.
Yeah, so that's a good point. You're exactly right, and Anchor is just a tool to do that.
Awesome.
Yeah, so that is a good point, because on the surface, when a container is deployed, each container should be on their own segregated network stack, which means that it shouldn't be able to communicate with other containers that are on the same host, but it can be configured to do so. So it is possible that public ports end up getting enabled, which can trigger that, or you do want to talk to some containers, but not all, throughout the containers on your host, and that ends up getting triggered or configured accidentally. So that's definitely a good one. I know we're running short on time, so I'll just talk about some other best practices. A good thing is to make sure that your container processes always run as a non-root or non-privileged user. So in the event that malware or something is able to take over your container, it then doesn't have advanced privileges to continue obstructing. Whenever you start up a Docker container, behind the scenes, Docker creates basically a set of what are the set of processes that are allowed, that this container is allowed to access, and what processes it's not allowed to access. And it also creates something called a control group, which pre-configures the CPU or the memory computing power that container is allowed to process. So it is kind of by default trying to prevent a DDoS attack from, or a DDoS attack that hits your container to then make take over your whole host. So it purposely will not will not allow it to get more of the CPU or computing process than it should. But then again, that's always by default, and it could be configured otherwise. So those are important things to check when deploying your container.
Something I'd add on to that too, Miriam, is Chris and Nigel, last week when you worked with AndroPyTool, remember you had to mount a local volume into your Docker container. So that means whatever has access to that container externally technically has access to a share that's mounted on the host itself. So I think an additional thing, and Anchor checks for this as well, be careful what which directories you decide to mount from the host directly into a container, because then the malware inside of that container can potentially have access to your entire host file system as well. It's another thing I would throw out there too. No, all good points, Miriam.
Thank you. Yep, that was all I had. And I can go ahead and share the article as well in the Slack chat, because I think it's really cool and fascinating. So I will share that with you.
Perfect. Yeah, thank you. And Nigel, I sent something to you. I'll send it to the group as well right now. There is an open source framework that is supposed to make the end-to-end contract development and testing experience more holistic. It's called Open Zeppelin. I think they only have support for Solidity. Not positive, but it is a framework for not only writing the contracts, but also for testing them. So it gives you an environment in which you can actually do what we did using my Ether wallet. You can do that locally. So that's an entirely local setup if you're interested in that. Just wanted to throw that out there. Well, good for us. It's 9:15, so I'm going to stop the recording.